Hello, this is Debdoot Roy Chowdhury, and today we're going to talk about forward list. Forward list is actually a container in standard template library of C++, which exactly is a singly linked list. Okay, what is a singly linked list? What is exactly the singly linked list? Singly linked list contains this type of nodes like this, and these nodes are divided into two parts. One is a data part, which contains some data, and an address part, which contains address of the next node this node is pointing to. Let's say this is our first node and this is our second node. These are not contiguous like array, so this is the second node. So this second node's address is stored in this part, the address part of this node. So whenever you try to access this node, you have to access this node too, because the address of this node is stored in this location. Okay, so this is our second node. Second node contains some data, maybe some integers, string, something like that, and then address. And this address part contains the address of the next node. This is our next node, last node you can say. This is also contains some data, but last node actually contains none in its address part. Why? Because this is a last node. It is not pointing to anyone, right? So this is why it is none. Now coming to forward list, how can you use it? So before using it, we need to declare its header file, include its header file in our program. So what does it header file look like? It's simple, it's hash include forward list. Okay, that's it. Or you can just hash include this header file, include this header file. This contains all the containers, all the STL libraries, algorithms, everything. Okay, so you can do either any of them. Okay, now how do we declare it? So we write forward list and we mention the data type of the forward list. It means what type of data you were going to store in this list. So if you are storing int, see here int, and you are storing integer data types. That's it. And obviously you have to specify a list name, and then you can specify the elements like this here, or there are other functions to enter elements into this list. Okay, so see here we are declaring a forward list without specifying any elements here. And then coming to operation, the first operation we have to see is assign. Okay, what assign does is if you declared a forward list like this without declaring any data inside it, you can enter assign a new set of values to forward list like this in third bracket, and that's it. If you print this, then you will see 1 2 3 here. And it can also be used to assign multiple values. Means if you have like this a forward list which is empty, now you can assign something like l1.assign 3 pi. What it will does, it will create a forward list of 5 3 times, 5 5 5 like this. Okay, cool, right? Yes, this is the assign. Okay, we will see its implementation at the end of the video. I'll first go through all the operations like this and define everything about them, then we'll see their implementation. Okay, next is push front. So what push front does is it actually pushes this element x at the front of the list. So here we can see an example where we have a forward list like 1 2 3, then we push 5 to this list. So what it does is pushes a new node 5 into the list, and it is in front, see, first position. This is what push front does. Now similar to this, another thing is pop front. So what pop front does is it just deletes the first element from the forward list, like the front element. Okay, and then you have emplace front. So what emplace front does is exactly similar to push front, but there is one difference. Emplace front actually directly moves that element to this list, but insert front, push front push front copies that element to the list. Next we have insert after. So what insert after does is takes an iterator and a value. So it actually uh, insert a element X after an iterator in a list. So whatever this iterator in your forward list, it will insert X next to it like this. Let's say here is an example. We have list like 1, 2, 3, and you know L.begin actually returns an iterator of the first element here, L.begin. So what I did, I inserted 4 after the first element, L.begin. This is an iterator, and after the first element, see, here is our 4. And it also returns an iterator of the new inserted element position. I mean this, 4. So what it does after inserting, it will return iterator. See, I'm storing it in IT. So of the newly created position. Okay. So this is what insert after does. Okay. And adding to that, you can also insert some kind of sub list into this list like this. We have an iterator and we inserted 5, 6 a forward list, another forward list. And what it does, we have an iterator here, because if you see the previous case, the iterator it returned this 4. So we inserted 4. This is our iterator, and we inserted 5, 6 after this. See, insert after it 5, 6. See, 5, 6 is added. Simple, and the iterator is changed to 6, this position. Okay, it will return the last position of the newly inserted element. Okay. Then there is also m place after, similar to insert after, but there is no copying, it just moves the element. Okay. And there is erase after. What erase after does, it will erase the next element of this iterator. So let's say if we have L.begin and we give L.begin as our iterator, it will delete the element next to it like this, 1, 2, 3. This is our iterator first, and we said L.erase after. See, this will delete the element, and it will also returns an iterator, but it returns an iterator next to the deleted element. Okay, so this is our deleted element, and its next element is 3, so it will return iterator of this element. Okay, that's it. And you can say that erase after actually takes 2 arguments, can take 2 arguments. So what it does, it will delete the elements between them, obviously including iterator 1. Okay. Then there is remove x, which is pretty simple. It actually, you have to give an element x, and it will delete all the occurrences of that element in this list. So if we delete 2, so our list will be like 1 and 3. That's it. Okay. Then there is clear, which is deletes the entire list. It will, if we have 1, 2, 3, 2, if we use clear, so it will delete the entire elements. Okay, so it will delete the all the elements from this list. And then there is empty. So what empty does, it is a conditional statement. So it will check if our list is empty or not. If it is empty, it will return true, and if it is not, it will return false. Okay? Simple. And there is reverse also. So what reverse does is reverse this forward list. So if we have like 1, 3, it will reverse like 3, 1. We'll see its implementation at the end of the video. And then there is also merge. What merge does is interesting. Merge actually sorted to forward list. Merge actually merges to sorted forward list. So if you have 2 forward lists like this, 1, 2, 3, and 4, 5, 6, these 2 are sorted, right? And if you want to merge, and if you want to join these 2 lists, you can use merge, and you will get exactly like 1, 2, 3, 4, 5, 6. So it will merge to sorted forward list, even if it has like this 1, 4, and 5, and you have 2, 3, 6, you will get this result 1, 2, 3, 4, 5, 6. Okay, cool. Okay, next we have sort function, which we already discussed in another video. It is an STL function. It actually sorts any container. So same goes to forward list. It will sort the entire list. And we also have another function called max size. It will return the maximum number of elements can be held We also have more functions like this. We'll cover that in another video. Now we're going to see all these functions in action. Let's see it. Okay, so here we can see that we included the header file of forward list, and obviously we used namespace yesterday, and then we declared one forward list L1 and assigned some values 1 2 3 4 like this. Okay, then we are printing, see, and %x, we are creating an iterator and just counting it. See, here is our output 1 2 3 4 forward list 1 1 2 3 4. Cool. Okay, next we are assigning values using the assign function. See, 5 6 7, and we are creating another list called L2. See, and we are printing this. See, 5 6 7. Okay, next we are moving to push prompt. See, 8, we are pushing 8 to list 1. See, then we are printing this. See, we are pushing 8. Here we have 8 1 2 3 4. Simple. And then what we are doing, we are pop prompt of list 1. We are doing pop prompt from list 1. So it will delete the first element. See, we are inserted 8 before this, so it will delete it. It will be 1 2 3 4, back to normal. Okay, then what we are doing, we are doing insert after. See, we are doing insert after L1 dot begin one iterator, and we are inserting 8. See, so what it will do, it will insert 8 after this element, after this iterator. So this iterator is first, so 8 will be the second element after this. See, 1 8 2 3 4, 8 inserted at the second position. Okay, let's see the next one. Next one we are doing, we're inserting another list in this after this iterator it. Now our iterator is in 8, so 9 10 will get added after 8. Okay, then we have erase after. So erase after iterator, so our iterator is now in 10. Okay, so because we actually see, we are actually returned, we actually stored the returned iterator here, it. Okay, and we are doing erase after this iterator, so 2 will get deleted because our iterator is into 10. Now 2 will get deleted. Now iterator will be pointing to 3. Okay, now we are removing 9. L1 dot remove 9. So see, forward list 1, after doing remove 9, we have no 9 left. 9 was there, it will get deleted. Okay. And obviously you should remember that it will delete all the occurrences of 9. If there have been some 3 to 4 9s, it will delete all the 4 9s. Okay, next we are seeing sort function. We are sorting both the list L1 dot sort, L2 dot sort. See, our L1 dot sort 1 3 4 8 10, it will get sorted, and obviously the list 2 will also get sorted 5 6 7. Now see, we are doing merge. We are doing L1 dot merge L2, so it will merge L2 to L1. So see, everything gets sorted 1 3 4 5 6 7 8 10. See, 8 10 is after 5 6 7. Okay, and obviously the reverse function, it reverses the list. Simple. Okay, so I will obviously copy this code into the description if you want to look at it.